Okay, we're going to do a little more with our triangle congruence proofs, and we're going to now add a additional reason, and it's going to be Cpctc, which is a little mnemonic that helps you remember that all 6 corresponding parts of 2 triangles are congruent. So even if you've only proven 3 pairs, you can go ahead and prove the triangles are congruent, and then different corresponding parts are congruent. So look at the definition of a congruent triangle is a triangle in which corresponding angles and sides are congruent. So the Cpctc means you're going to have, let me underline these words, the corresponding parts of congruent triangles are congruent. That's where this comes from, Cpctc. Look at the 2 triangles in example 1. If they're congruent, if triangle CAT is congruent to DOG, and you want to list all the congruencies, you can list 3 sides and 3 angles. If you don't have a picture, you can look at the order of the letters in your congruent statement. Since C is the first letter and D is the first letter, those are congruent angles. I'm going to go ahead and mark those. C and D are congruent. A and O are the second letter of each in the congruent statement, so these are congruent. And then T and G. I'll use 3 little curves to note that those are congruent. Those are all the angles. When you look at the sides that are congruent, again, you don't really need a picture because you can use the order of the letters. Since CA are the first 2 letters in the congruent statement, right here, look at this right here is called the congruent statement. You can use that to help you name the sides and the angles. So naming the sides, CA and DO, you're naming those 2 sides. AT and OG are congruent, and CT and DG are congruent. So I use different number of tick marks to explain that. Those are called the 6 congruencies of these 2 triangles. So how many congruencies does it take for us to show the 2 triangles are congruent? You remember you only need 3, because the 3 congruencies, you need side, 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 angle, side, or angle, side, angle. Those were the 3 congruencies. So how many additional congruencies could be deduced? There are 3. That just means that since there's 6 total, and you only need 3 to prove congruent, you can use Cpctc to name another congruency. Alright, let's make sure that makes sense. Let's do a proof together. Look at page 2, or example 2. This time, if you notice, we're going to require an extra step. So the next to the last step is going to be one of your congruent statements, and then you'll have to use Cpctc to prove that S and T are congruent. So let's start with the given. RZ bisects the angle TRS, and that's a given. And that word bisects does mean that it will take that angle and break it into 2 congruent parts. So that shows me that these 2 are my 2 congruent parts. And they're numbered 1 and 2, so that means angle 1 has to be congruent to angle 2. That's just the definition of bisect. DEF just means definition. The other given is angle 3 is congruent to angle 4. So that's the next statement. I'm going to go ahead and mark those congruent. I'll use 1 tick mark. That's a given. And again, this one's like one we've done before where they're sharing, these 2 triangles share a common side, which is RZ. It does look a little interesting to say that RZ is congruent to RZ, but you can do that because of the reflexive property. And now we can prove the triangles are congruent. Now when you do this part, make sure when you name your triangle, I'm going to name the top triangle RZT. When I name the bottom one, I need to name the congruent angles in the same order. So I'm going to use R and then Z, and then this time S, because S and T would be congruent, just like Z and the Z's are, this vertex right here is congruent. So let's look at our congruents. We have a congruent pair of angles, another congruent pair of angles, and a congruent pair of sides. So that means our side is between our two angles. Oh, I forgot to mark it. Let's do a tick mark to do that one. So that one's angle, side, angle. But we have an extra step because we're proving that S and T are congruent. And remember, it only takes 3 congruences to prove a triangle is congruent. So that's when we get to use corresponding parts of congruent triangles. We know that even though we haven't proven using what's given, we know that because the triangles are congruent, that they are congruent. Let's try example 3. On this one, starting with the given, we have that AB bisects CD. That's given. Let's go ahead and mark our pictures. Since AB and CD are bisectors, that means M's in the middle of both. So we have these the same and these the same. Those are called, wait a minute, AB bisects CD. Oh, I did that wrong. These we don't know. We don't know that those are the same. We just know that AB cuts the middle of CD. So CD is the one we know has the equal parts. So CM is going to be congruent to MD. That's just definition of segment bisector. Okay. We're given another information in our given that C and D are the same angle. So let's go ahead and do a curved tick mark to mark those the same. Now, if you notice, we have a side between two angles, and I'm going to show you that we can mark this angle right here and this angle right here. If you remember, those are called vertical angles. So angle AMC is congruent to angle BMD. Those are vertical angles. Vertical angles are always congruent. So it looks like we have enough congruence. We have a pair of sides and then 2 pair of angles, and the 2 angles are on each side of the side. So that's why the S would be in the middle, and the congruent statement would be that triangle ACM is congruent to triangle DBM. Oh, I did that backwards. Sorry. That would be DBM. You do have to put, it does matter. The order of the letters, I know I'm making this kind of messy, but D, the reason I'm picking D, oh, I did do that wrong. I don't want this to be this messy, and I want you to be able to know what you're, because I'm kind of messing this one up. Let me wipe that out. Okay, A right here is going to be the same as B. C is the same as D, and M is the same as M if we were looking at the 2 triangles separately. So you do have to write your congruent statement with the congruent angles in the right order, the same order. But if you'll look at what we're trying to prove, we're proving that the angles are the same, A and B. And see how those angles are not marked on my picture. We didn't know anything about those 2 angles being congruent until we proved that the triangles were congruent. That's how we know now that they're congruent, so we can use Cpctc. Alright, let's do one more. You know, sometimes a good way to do these notes would be to turn the computer to pause for a minute and then try it on your own and see if it matches the one that I'm teaching you. So that's kind of a way you could know if you're doing these right. But I'd use a pencil so you could erase if you messed up. Alright, M is the midpoint of AB. I kind of like starting a proof because it's just copying. You just get to write what you already know. So that's just a given. Let's go ahead and do the definition of midpoint. Remember, when you define the word midpoint, you have to name the segments that are congruent. So look at the picture. AB is the line across the bottom. If M is in the middle, that means that the length of AM has to match the length of MB. Those are congruent. So there's our first congruent statement. Looks like they were given the other two. We're given angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. That's kind of nice. They're giving us lots of givens. I'm going to go ahead and mark those. 1 and 2 are the same. 3 and 4 are the same. So do you see how we have 3 congruent statements? It only takes 3 to prove it congruent. Just remember what letters you're going to use. You have 2 angles and a side between them. So you have angle, side, angle. And when you write your congruent statement, start with a picture of a little triangle. The first triangle doesn't really matter how you write your first 3 letters, but the second triangle on the congruent statement, it matters. You need to have them in congruent order. So A is congruent to B, so I need to start with the letter B. C would match D, and M would correspond with M of the second triangle. Now that we know the triangles are congruent, we can prove that our segment AC is congruent to the segment BD. So Cpctc is always going to be one of the last things you use, and it's always used to prove corresponding parts after you've proven the triangle's congruent. So make sure the one right above it will always be one of your congruent statements for triangles, and then you can use Cpctc. It's kind of an extra step. It's a little bit more than what we did in our last topic. Okay, now let's try some on your own.